So before we even start finding the derivative and stuff like that, what stuff do we try to find from the original function if we can, if it's possible? Yeah, x-intercept, y-intercept. Okay, so how do I find the y-intercept? Plug in 0 for x. That's probably the easiest thing to do, is the y-intercept. So 2 times 0 minus 4 to the 2/3. Okay, so I've got, that's 0. So I've got the negative version of negative 4 to the 2/3. I don't know about you guys, but I don't know how to do the third root of negative 4. So instead of doing the third root of negative 4, I'm going to think of negative 4 squared. Okay, so negative 4 squared is 16. So I've got the negative version of 16 to the 1/3, which is the negative version of the third root of 16. And is there a perfect cube in here? There is not, or there is? It's 8, right? Okay, so we've got, this is the cube root of 8 times the cube root of 2. Okay, so the cube root of 8 is 2. So this is negative 2 cube root 2. Okay. Don't know how I'm going to graph that just yet, but we found it. So that's cool. So I've got my y-intercept is 0, negative 2 cube root 2. Okay. X-intercepts, what do we do? Okay, so 0 equals negative 2x minus 4 to the 2/3. Okay. And then what do I do? We can divide by negative 1, it still equals 0. So we can raise both sides to the 3/2. So 2/3 raised to the 3/2, that cancels those out, they're just to the 1. 0 to the 3/2 is still 0. And the 4 over, divided by 2. Okay, so the x-coordinate, or the x-intercept is, okay, thank goodness that is something we can graph easily. Okay, let's figure out how to graph this. So the cube root of 1 is 1. The cube root of 8 is 2. So the cube root of 2 is somewhere between the cube root of 1 and the cube root of 8. It's much closer to the cube root of 1. So this is pretty close to negative 2 times 1. So it's a little bit more than negative 2, but not. It's hard to guesstimate that decimal. I'm just going to cheat real quick and see what that is. Because my brain not working. Cube root 2. Negative 2.5. Did not see that coming. Negative 2.5. In the past, I have, for this particular, I'll have to look and see what types of questions actually require you guys to graph. In the past, I allowed students to use a 4-function calculator, but then we actually had to track them down. We ended up borrowing them from the science department at my old school, but I don't know if our science department has 4-function calculators. So I'll look at your guys' assessment for this unit and see if I end up even asking you guys to graph any of these, and if there are questions where decimals are necessary. It depends on what type of question we end up having. Okay, x-intercept, y-intercept, we got it. So what part are we moving on to now? First derivative. All right, so taking this question, go ahead and find the first derivative. Okay, and that's, so here's what I got for my first derivative. Is that what you guys got? And then I cleaned it up a little bit. I did the 2 times 2 and I got -4 on top. And I got the 3 on the bottom. And then I did my -1/3. I wrote that as a cube root on the bottom. Okay, so is there a spot where the derivative equals 0? No, because the top just has a 4. Is there a spot where the derivative is undefined? Yes. What is the x value? 2. So it's just the 2x minus 4, and that's going to be an x value of 2. So the derivative is undefined at x equals 2. Okay, so we're going to go ahead and we're going to make a sign chart with x equals 2. Now keep in mind the top of your derivative is already negative. So keep in mind that you do have that negative on top. All right, so what's a number that's smaller than 2? Let's use 0 because it's easier to plug in, okay? All right, so 2 times 0 is just 0. If we do the cube root of a -4, I don't care what number it is, it's just negative. Doesn't matter what it is, it's just negative. So we have a -4 on top divided by a negative on bottom, and what do we get? Positive. Okay. What's a number that's bigger than 2? 3, okay. 2 times 3 is 6. 6 minus 4 is 2. I don't care what the decimal is, but the cube root of 2 is positive. 3 times positive is still positive. So we got a -4 over a positive, and then what do we get? Negative. Okay, so based off of this, what information have we now picked up on? So we have the increasing interval, we have the decreasing interval. What is the increasing interval? -infinity to 2. The decreasing interval is 2 to infinity. Say it again. Would it be a realistic max if it's like on the bottom of the other line, or would that be it would be a max, it just is not gonna be yeah. All right, so we have positive to negative, so we have a relative max at x equals 2. And actually, we do know the y-coordinate of that point because we know that x equals 2 is where that x-intercept is. And so we know this 2, 0. If it had been a different x value than 2, then what would we have done to know what the y-coordinate was? We could have plugged it in. Yeah, okay. All right, so we are done with the first derivative. What should we do now? second derivative. So I'm going to start with the first derivative being negative 4/3 times 2x minus 4 to the negative 1/3. I'm going to use that version of the first derivative because that's going to be the easiest version for me to work with. And I'll go ahead and find my second derivative. So I did my outside 2 times my 4. I did my 9 on the bottom. Now your 3 still means a cube root. That 4 on the top, that can be the whole thing to the 4th, or it can be the inside to the 4th. It's however you choose to write it. It doesn't matter. So can my second derivative equal 0? No. Can my second derivative be undefined? Yes, it can be undefined at what value for x? 2. It's undefined at x equals 2. Okay. Now, this time the top is positive. And this time, if we look at the bottom part is raised to the 4th power. The bottom part is always positive no matter what you plug in. So the top is always positive because it's an 8. The bottom is always positive because it's something raised to the 4th. So no matter what we plug in, we got a positive. Say that again. So it's concave up the whole time. So we're going to say concave up, and what are we going to write for that? What are we going to write for concave down? None. What are we going to write for point of inflection? None. So since it's positive, it does not have a point of inflection. It never switches concavity. Okay. So I'm going to go ahead and kind of box all these answers so I know what I'm drawing. Now, one of the things that I said in the video that is helpful is symmetry. Is that unless you're graphing a polynomial function, a lot of graphs have symmetry. And what we know is that anytime you're dealing with a graph, like cube roots do have symmetry. Graphs that are squared do have symmetry. A lot of the graphs that we deal with do have symmetry. So if we start with this, we know that we have a relative max at 2, so this is the high point on our graph. We know that the entire graph is concave up. So we know that the entire graph kind of looks like a bowl shape. Does that make sense? The entire thing looks like a bowl shape. We know that the graph is increasing from negative infinity to 2. And we know that the graph is decreasing from 2 to infinity. So I know that it's going up right here, I know it's going down right here, but I know it's not straight like I drew it. I know it has to be concave up. So how do you guys think that I should fix what I drew? Draw it like a cusp, okay, and draw it so it's got to be kind of bowl shaped like that. So it's got to be like this. It's not going to come back around like this because that would make that side decreasing over here. So it's going to have to stay like this. And there's going to be some symmetry here. So I'm going to say this is kind of like an axis of symmetry right here. So I'm going to go down over here and draw another point that's kind of symmetric to that y-intercept. And then I'm gonna draw, there's my concave up on the other side. So we can see here is our relative maximum, but that derivative doesn't exist. You guys see that? So it has a relative max right there, but there's not a horizontal tangent right there. There is no derivative right there because the left slope and the right slope don't agree with each other. I can see that it is in fact increasing on the left side, increasing from negative infinity to 2, decreasing from 2 to infinity. It has that y-intercept, it has that x-intercept, it is concave up the entire time. It has no point of inflection, so it fits all of the information. Okay, how are you guys feeling about it? Whew, little bit messy in your brain? Okay, I do think we did just do the most difficult problem in the packet, though. So I think that the other ones are a little bit more comfortable. So 1 through 5, you are drawing the picture. 6, you are not drawing the picture, you're just finding the information. Okay? Go ahead and work on those. I'm going to be working on your cheat sheets unless you ask me questions. Okay? Yes.